You're going to want to start with a horizon line. You're going to want your center line. And then you want to establish your station point. After you've established that, you're going to create your picture plane. And then you're going to establish your vanishing points. And then the last thing you'll do in setting up your system is to establish either a 45-degree vanishing point or your measuring points. So these are 45-degree VPs and measuring points. Okay, so I'm gonna start. We'll start with 1 point perspective again. So starting with your horizon line. Now you can actually you guys should probably use rulers for this when you do the test. If you don't have a ruler, you can actually fold a piece of paper and use that as kind of a straight edge. Although preferably probably just use a ruler. Alright, so using a ruler, establish a horizon line and a center line. You want these to be as perpendicular as possible, meaning like 90-degree angles here, perfectly that way and that way. Station point. Again, this is always kind of something that you just set for yourself. Wherever you want your station point to be is really fine. You just want to make sure that when you create your rectangle of the picture plane that the station point is below the bottom edge of that rectangle. So in this case I'm going to set up my picture plane about here. And with the picture plane you just want to make sure that the center line is going to be in the middle of your picture plane. So this is just a rectangle that basically represents your cone of vision as the viewer. Okay, and in 1 point perspective, we will have our singular point right here. That's your VP. So we've established horizon line, center line, station point, picture plane, vanishing point. Now what we need to do is set up our 45-degree vanishing point. In the case of 1 point parallel perspective, it's always going to be your 45-degree vanishing point that you're doing. So you can do this by taking a piece of paper, and if this is the corner of your paper, you fold it in half, like that, because the corner of your paper is originally a 90-degree angle, so this would be at a 45-degree angle. Okay, you bring that so that this edge is parallel or running along the center line, and that this corner right here goes to the station point, and this is 45 degrees. So if you follow this edge out to the horizon line, that's where you're going to find your 45-degree vanishing point. Okay, and you want to really make sure that that's actually 45 degrees. So make sure you use this trick. Or you can use a triangle if you have it. I'm just saying if you don't, this is how you can do it. Okay, so this is always going to be 45 degrees. Alright, so having set up this system, you're going to want to build a box or a cube. So you can start setting this up wherever you want. In this case, we'll do it here. And I'm just going to start with the line that will represent kind of the front bottom edge of the square. It's going to be on the ground plane. Okay, going from here, we're going to set 2 lines going back to our central vanishing point. And from here, we just want to figure out, because this is kind of going endlessly back into space, we want to figure out how to make that an actual true square. Okay, we'll do this by running a line from our 45-degree vanishing point to the farthest front corner, which is here. Okay, we run this line from that corner going across like this. Where that intersects back here will be a true square. So this is where you draw your rear horizontal line, and this is basically going to be the bottom plane of our cube. All right, so next we'll want to establish the height. So you're just going to take, again, just a piece of paper like this, make a mark at one end of the front edge and at the other. You can turn that vertically like this and get the height, which is going to be up there. So you just need to run your horizontal across the top and your two verticals running up to that horizontal line. Here and here. And you just want to make this as straight and vertical as possible. Alright, next we're going to start these two upper right and left corners. We're going to run lines again back to the central vanishing point. Okay, and what we could do is simply run lines from these back corners here and here up to the diagonals. Or you could, again, use your 45-degree vanishing point to establish where that back corner is going to be. Should be directly above this corner back here, like that. Okay, so you go to that diagonal, run your horizontal across, and another vertical up from that back corner. Okay, and that would be the top plane of your cube. Alright, so that's a true cube in 1 point parallel perspective using a 45-degree vanishing point to determine the depth of the cube. Okay. Alright, next we'll go into 2-point parallel. Alright, this will be 2-point parallel perspective, the same exact order of things. We're going to start with the horizon line and the center line. And then we're going to establish our station point. Again, this is wherever you want it to be. I'm just going to put it down here. And next we want to give ourselves a picture plane. So this is just going to be a rectangle with the center line right in the middle. And the station point below the bottom edge of the rectangle. Again, we want this to be in the center as much as possible. If you want to be absolutely sure, just make a mark here using a separate piece of paper, and you can move that across and make sure that it's perfectly centered. Okay. Next we want to establish our vanishing points. So this is 2-point parallel perspective, so this is going to be a symmetrical 45-degree 2-point perspective system. So again, you want to take your piece of paper, fold it on the corner, and you can bring this up to the edge of the center line so that the corner is right there at the station point, and this should go out to the horizon line, establishing your vanishing point number 1. And you do the same thing over here. That will hit your horizon line, making vanishing point number 2. You can also, in 2-point parallel perspective, because these are right-angled triangles, this distance from the station point up to the horizon line is going to be the same distance as from the center line horizon line intersection to vanishing point 1 and 2. So you could, and actually this is probably the most accurate way to do it, is just take a piece of paper, take that distance from the horizon line to the station point, turn it this way, and that should give you your vanishing point number 2 right here and over here. All right, so this is two-point parallel perspective. Next, we want to, in this case, in the case of all the two-point perspectives, you're not using 45-degree vanishing points. Although you can, your 45-degree vanishing point would be right in the middle. But in this case, we want to establish measuring points in particular so that we can take the height or the depth of a cube and translate that to the height and vice versa. So to get your measuring points, again, you can take a piece of paper and do this. You're just going to take the distance between the station point and your vanishing point. Okay, so vanishing point 1 is here, and the station point is right here. And you're just going to take that distance and swing it up to the horizon line. So that would be where your measuring point is, where this distance is the same distance as that distance. Okay, this is MP1, or measuring point 1, because we're using this line that's going to vanishing point 1. Okay, the same thing will apply this way. You take the distance from the station point to measuring point number 2, rotate that out along the horizon, and this is your measuring point 2. Okay, it's the same distance from vanishing point 2 to measuring point 2 as from vanishing point 2 to the station point. So this distance equals that distance. Okay, and when you make a cube in this perspective system, you want to first kind of just figure out where you want the front corner to be. And this could be anywhere you want. I'll just put it right here. And we're going to start by making this V shape. Okay, this will be the first 2 front edges, left and right, of a cube. And we're taking lines from this single point to your vanishing points 1 and 2. To establish a height, there's 2 ways you could do this. You could either go on ahead and kind of establish your depth and make that whatever you want and translate that to the height, which is kind of what would normally be the reverse order of doing it, or you can establish the height of your cube first and then use that height to make the depth. So just to kind of keep it simple, I'll start with the height first. We're going to run a vertical line to just here. This could be any height you want it to be. And what you want to do is take that height and translate that along a horizontal line coming from the front corner. Okay, so if you lightly draw a horizontal line out this way and take that distance that is the height and move it along that horizontal to here, you're going to start here and run a line to measuring point 2 so that it crosses right here. Because we're trying to find a distance going along a line that goes to vanishing point 2, we're going to use our measuring point 2 to find that. So it's just taking a line from here to here, and where that crosses, that's going to be the same distance going back into space along this line as the height of your cube. So this is where you're going to draw your vertical line. This is the very farthest right edge of your cube. And then starting at the top, you run a line back to vanishing point 2. And this is going to be the right side plane of your cube. Okay, starting at the top again, you'll run your other top edge going back to vanishing point number 1. And in two-point parallel perspective, one of the nice things about it is that you can take a horizontal line from this far right edge to find the farthest left edge here. You can also do the same process that you did to find this edge. You can take the distance of the height of your cube and run that along this way, horizontally from the front edge. And you can run a line from that point right here to your measuring point 1. And you'll see either way works because that will cross this line at the same point here, horizontally connected to this other corner. Okay, so once you've established that, by either method you will draw your vertical line. This is going to be the left side of your cube. And then from these 2 top corners, you're just going to run lines to vanishing point 1 and 2 so that they cross. If we want to do this transparently, we probably actually want to finish the bottom of the cube first. So you can do that and that. All right, this is going to basically make the bottom plane of the cube. And this is the back corner, so one of the other things about this type of perspective is that when you connect the front and back corners, they should connect on a line that goes to the central point here, which is really your 45-degree vanishing point in two-point parallel perspective. Okay, last thing you'll do is take these top left and right corners of the cube, run lines from there to vanishing points 2 and 1. And that will give you the final top plane of your cube here. All right, so that's your cube in a two-point parallel perspective. All right, two-point angular perspective. Again, same process we're following. We're going to do the horizon line first, followed by the center line. And actually, when you do your two-point angular perspective, you probably want to put the center line kind of more to the left of your page or to the right, because your vanishing point is going to be kind of off-center, pretty far one way or the other. So in this case, I'll move the center line a little more to the left side of my page. So here's our center line, station point, wherever you want it. I'm just going to put it down here, and then create my picture plane. Okay, this is just a rectangle that starts with the line above the station point and has the center line that runs right down the middle. Okay, so establishing your station points, or your vanishing points in two-point angular perspective. The thing to remember is that if you take a piece of paper like this, this is a 90-degree angle. Okay, so if you take that corner of your paper, line it up to the station point, you can pivot this way and that way, and wherever these edges hit the paper, here and here on the horizon line, those are going to be your two vanishing points, because it's always at a 90-degree angle from vanishing point 1 to the station point out to vanishing point number 2. Okay, and so the whole thing that makes it angular perspective is that this is different than this distance. So this is your VP1, this is your VP2, and it's just angular because it's kind of offset. It's not a symmetrical 45-45. This is, say, 40 degrees and 50 degrees. Okay, so that makes it kind of, because it's a non-symmetrical layout, that's the two-point angular perspective. Okay, so with two-point angular perspective, once you find your vanishing points, you then want to get your measuring points. So same process, just take the distance from vanishing point 1 to the station point and transfer that along the horizon line. So that distance here is going to go out from vanishing point 1 along the horizon line, the same distance. This is your MP1, or measuring point 1. So this distance here is the same as that distance. We just swung it up this way. Okay, same thing with your measuring point 2. You're going to take the distance from station point to VP2 and move that along the horizon line this way. This is your MP2, and the distance from MP2 to the vanishing point is the same as from the vanishing point 2 to the station point. So that equals that. And again, we just swung that distance up this way. Okay, so once you have these, then you can start to make your cube. Okay, so it's the same thing as two-point parallel perspective. You're just going to find out where you want your front corner to go, and this could be anywhere you want. We'll put it over here. And from this point, we're going to run lines out to vanishing point 1 and vanishing point 2. Okay, so this is going to go to VP1, This is going to go to VP2. Okay, so here, again, we'll establish a height using a vertical edge. I'll just keep this below the horizon line. And what I'll do next is use the measuring points to find the distances that are equal to the height, going back into space. So you can just take a piece of paper. You're going to take the height of your cube, transfer that along a horizontal line from the bottom corner out this way, and you'll probably want to just do the same thing on the other side as well. Okay, so you're just taking this distance, moving it that way and that way. Okay, so this is the edge that goes to vanishing point number 1, so I'm going to use measuring point number 1 to find a distance along that edge. So starting here, running a line to MP1. Okay, where that intersects here, that's the same depth as the height. Same thing over here. We go from this point to measuring point number 2. Where that intersects right here is the depth that's equal to the height of your cube. So from these 2 points we run 2 short verticals, and then starting at the top of your cube here, you're going to run lines back to vanishing points 1 and 2. So the really important thing to remember, and the thing where most people screw up, is just to remember that no lines, no actual edges of your cube are going to go to measuring points 1 or 2. They go always to the vanishing points. You're just using measuring points to find the depth. Okay, but you don't want to actually use these as edges for your cube. Okay, so once we have all these corners, we're just going to then run lines back to vanishing point 2 and 1. So that they cross in the back corner. Okay, so this is going to be the bottom plane of the cube. Doing the same process here on the top, running lines from the upper right corner to vanishing point 1, from the upper left corner to vanishing point 2, so that they cross, will give us the top square. Last thing we're going to do is connect the back corner with another vertical. Okay, and that's a cube in 2-point angular perspective. All right. Lastly, 3-point perspective. Okay, basically same process. The only thing that's different in this case is that we're going to put the horizon line up. Here. And then we're going to do our center line. And when we draw the picture plane, it's going to be below the horizon line. Again, establishing a station point. This can be wherever you want. I'm just going to put that here. And what you want to do to get your first 2 vanishing points is to get 45 degrees out from the station point this way and this way to the horizon line. So again, just take a piece of paper, fold it at the corner, okay, and bring that to the station point. Okay, so remember this is 45 degrees. So this will give you your vanishing point number 1. Do the same thing this way. Okay, bring that corner right there to the station point. Again, that's 45 degrees. So that gives you your vanishing point number 2 right here. Now, to get the third point, you want to take the distance from vanishing points 1 and 2 and move that down this way so that the distance from vanishing point number 1 and 3 is the same as from 1 to 2. Or the distance from vanishing point 2 to vanishing point 3 is the same as from vanishing point 2 to vanishing point 1. So you're just making an equilateral triangle here with all the edges being equal. So you can do this again with a piece of paper. Get the total distance between vanishing point 1 and vanishing point 2, and just pivot that from, say, like vanishing point 1 until it hits the horizon line, or sorry, the center line, which I'll have to extend down a little bit. Okay, and that hits right about here. Okay, you can check that again this way, VP2. So it hits the center lines right here. So this is going to be my vanishing point number 3. And you actually want to, in this case, connect your vanishing points, the line, so that you actually get the triangle. Okay, so that's an equilateral triangle. That is equal to that, which is equal to that. So lastly, I should probably establish a picture plane. Again, picture plane, you want that to be below the horizon line. And you want the center line to run down the middle, so you want that distance to be the same here and there. Okay, so that's your picture plane. The station point can be in the picture plane in this case. Okay, so this is the one system where that can happen. And then lastly, your 45-degree vanishing points. Okay, so along the horizon line here, it's always halfway between the vanishing points. So between vanishing point 1 and 2, the center line's right in the middle. So this is going to be our 45-degree vanishing point number 1. You also want to get the halfway point between these 2 points here and here. So you can actually just take, again, a piece of paper, take that distance and swing it down here, and that will establish your 45-degree vanishing point number 2, and doing the same thing this way, you'll get your 45-degree vanishing point 3. And these should basically sit on the same horizontal line. Okay, having done that, you can now build your cube. So you just, again, want to start with a front corner, top or bottom. In this case, I'll start with the top corner. So I'm going to start right here. This is going to be the top plane of a cube, so the very top square. Running a line out to vanishing point 1 and 2. And you just pick a depth that you want this to go back. So let's say I want it to be back here. What you're going to do is take that depth, run that back to one of the vanishing points, and then you can do this one of 2 ways. You either run a horizontal line from here over to here, or what's probably better is to use this 45-degree vanishing point and run that from the front corner of the top square to the 45-degree vanishing point. So that would be like that. That will intersect back here, and you'll run a line from VP1 through that point. And you'll see that will end again right here on a horizontal line. So this is your top plane. Okay, in the left and right corners, because this is right at this point, it's basically a 2-point parallel perspective system. The left corner and the right corner align horizontally. The front and back corners align going to the central 45-degree vanishing point. Okay, now we got to get the vertical edges, and in 3-point perspective, all the vertical edges are going to your third vanishing point down here. So starting at all 4 corners, you just want to run lines down to vanishing point 3. Including this back corner here, draw it transparently. Okay, so now you have side planes. All right, so to square these out, to make sure that the height is the same as the length here, we're going to use this 45-degree vanishing point, okay? Because this plane that I'm starting with, going out this way, this is going toward vanishing point number 2. So this is the 45-degree vanishing point that I want to use. You're going to run a line from this 45-degree vanishing point to the top corner, like this. When this line intersects with this line right here, that's going to be the same height as the length this way, or the depth. So you'll run a line from vanishing point 2 through that point until it hits the front edge of your cube right here. So this becomes the right side plane. Okay, and because we use a 45-degree cut right here, this is 45 degrees, that's 45 degrees. And that makes 2 right triangles, which makes a square that has the same height as its length this way. Okay, once you find this bottom corner, you can basically just run a line back to your vanishing point 1. That will make the other edge, the left edge right here. Okay, and again, if you took these 2 corners, connected them, they would take you to the 45-degree vanishing point right here. Okay, so again, it's 45 degrees right here, 45 degrees right here. Okay, and that makes your cube. Just to kind of finish up, draw these little back edges here that finish the transparency. Okay, and again, you'll see the front and back corners of the bottom plane connect going to 45-degree vanishing point up here, and the bottom left and right corners align horizontally. And that is your cube in 3-point perspective.